What's up, Stemheads? Today we're here at Chevron to interview Brian Stock to see how they use oil and gas. Let's go. Hey Brian.
Hey Liam, how you doing today?
Good. Thanks for taking time to meet with Stemheads and the Utah Manufacturers Association.
Yeah, you're welcome. I'm excited. Thanks for taking the time to visit the refinery.
Would you mind if I asked you a few questions about your company?
Not at all.
Alright, let's do it. So I've heard that you use fossil bones to make fuel. Could you explain that?
Ooh, that's a good question. We do. The fuel that we start with at a refinery comes from deep below the Earth's surface. We call it oil or sometimes wax. I actually brought an example for you. So this is a wax that comes from the Uinta Basin right here in Utah. And this is what we start with. And you can see at room temperature, it doesn't really want to move around. It's pretty stable. And so that's something that's difficult to use as a fuel. But we have the ability in the refinery to take something that starts like this and turn it into a clean burning fuel like this. That's easy to transport, that has all of the contaminants taken out of it, and that has high energy so that people can use it to power their vehicles or their homes.
That's really interesting.
Yeah,
I never
thanks.
knew that. How many steps does it take to convert it?
Well, usually the first step is heating it up. So when you start with something like this, if you heat it up, then it can turn into a liquid and it can flow. That way we can pump it around and we can process it more easily. So usually heating it up is the first step. And then the second step, a lot of times, would be applying pressure. Third step would be using a catalyst or some sort of chemical to create a reaction. So what we're basically doing is we're taking the molecules inside and we're rearranging them to turn them into something slightly different. And by doing that, we can create these types of fuels. And then as we continue through the process, usually we have to cool things back down. And then some of the final steps would be removing contaminants. So when this comes from the ground, it can have natural elements in it like sulfur or nitrogen or different types of metals. And we don't want to have those in our fuel. So we have processes that will remove those or convert those into something different.
That's really cool.
Yeah, thanks.
How would you say Chevron benefits our day-to-day lives?
Well, that's a good question. So Chevron provides the fuel that we all need across the country. And in our day-to-day lives, we use fuel for a lot of things that people maybe don't recognize or appreciate. So in the winter, fuel helps keep us warm. In the summertime, fuel can help keep our houses cooler. Fuel is a feedstock for electricity. So at nighttime, when you have the lights on so you can spend more quality time with your family, that's coming from fuels. People use fuel to be able to cook their foods all around the world and in the country here. And it just supports everything that we do. One of the freedoms we have here is the ability to be able to travel where we want to, when we want to. And so Chevron provides fuel for cars. We provide fuel for airplanes so you can fly to places efficiently and quickly. We provide fuel for railroads so that trains can deliver products all around the country. Those are some of the examples of ways that we help support the quality of life here in the United States.
Wow, I've never used how much fuel is going into everything.
It's amazing, huh?
Why would you say Chevron is a great place to work?
I think Chevron's a great place to work because it takes really good care of its employees, but what I like most about the company is the people that I work with. I work with a lot of smart people that help provide the fuel that the world needs, but also care about the community and the environment around us, and are continually looking for ways to be able to create ever cleaner fuel.
What jobs or careers do you have here that involve STEM?
Gosh, we have jobs here that involve all kinds of sciences. Personally, I think you would be a great equipment inspector. Some of the people here have special certificates to go inside of our equipment to inspect everything to make sure that it has good integrity, that it's functioning the way it's supposed to. And although our equipment is really big, sometimes the doorways to get in and get out can be pretty small. So I think you and your friends would be really good at that. But we have a lot of other STEM-based careers. One of the more common one is probably engineering. So I'm a mechanical engineer, but we have chemical engineers and electrical engineers and civil and structural engineers. We have environmental engineers and software engineers, and so I'm surrounded by engineers every day.
Maybe I should work here in the future.
Hey, that would be fantastic. We also have a lab that I'll show you later where we have chemists that test all of our products to make sure that all of our fuel goes out here the way it's supposed to. We have a lot of people that support our computer systems. In our industry, we have a lot of data and a lot of information that we have to manage. And that helps us operate more safely and efficiently. But we need computers and other technology to be able to process that information. And so we have software engineers and computer professionals that help keep all of those systems in good working order. We also have people that are really good at math that work in our finance department. And they help manage our checkbook and make sure that we pay our taxes properly and that we have money available to support community outreach programs and that families get their paychecks on time. And so we have careers for all types of different STEM interests. We also have some people that are not only smart, but they're really talented with their hands. And we need those types of people. We need people that can do welding and people that can machine critical parts for our machinery and our equipment that we have. We need people that can do electricity and maintain some of our electrical equipment and our sophisticated instrumentation. And so those offer really good careers for people too, going through trade school programs.
That's awesome.
Yeah.
What is Chevron doing to help with the clean air?
Oh, that's a good question. Here in Utah, we're doing a couple of new things. When we have poor air quality days or air action days here in Utah, we actually encourage our employees not to drive to work. It sounds a little counterintuitive, but that's one way that we think we can help improve the air quality is by allowing our employees to work remotely and not have their vehicles on the road on air action days. We've recently made a lot of investment in being able to produce something that's called Tier 3 gasoline. So we have special chemistry that removes more sulfur from gasoline that goes in vehicles. And that way vehicles that travel the road are able to burn more cleanly and efficiently and have fewer emissions.
This is really fun learning about all fuel types and what you guys do.
Thanks, I'm excited to share it with you.
So going into the future, what are you guys planning on doing with all these electric cars coming out?
Well, that's a good question because I do see a lot more electric cars on the road today. And some of the people I work with drive electric cars. I think they're kind of neat. But Chevron believes that electric cars aren't going to be the only solution. So what we're really good at is finding other fuels that can help provide a better environment around us. Some of the exciting things that we're working on today include things like hydrogen, which is a cleaner fuel that we think can power locomotives and ships and trucks that deliver items to your house. We're also working on something called renewable natural gas, which takes gas off of things like landfills or cow poop off of farms, and you can turn that into a renewable gas that people can use for heating in their homes. We're also working on some other exciting stuff related to renewable fuels. We can actually today, with our technology, make fuel out of things like corn by converting it to ethanol. We can convert soybeans into fuel, and even most recently we can turn peanuts into fuel. And I actually think you and your friends, with all of your STEM learning that you're going to have and all of your inventiveness that's inside you, I think if you pair those things together, you guys are going to come up with something that we haven't even thought of yet.
That's crazy.
Yeah, I think you will decide what the future of energy looks like, and I'm really excited to see what you come up with.
All right, I'm most excited to see this magnificent facility.
I'm excited to show it to you. This is my favorite part. So let's go get our safety clothing on and let's go outside.
All right, let's do it.
All right, I'll follow you.
So all of this equipment gets designed by engineers. So they decide how big the equipment needs to be, and how thick it needs to be, what the insides look like to be able to create the process. So all of that gets designed by engineers and drawn on paper and in the computer. And then we send those drawings to a fabrication shop where they build everything out of metal. And then we bring it here and install it, and then we operate it. And if you look at the very, very top of the stack, can you see the flame coming out of it? So that's what we call a pilot light. So there's always a small flame that's burning on the top of the stack. And that stack we call a flare, and it's a safety device. So if something happens and we have too much pressure inside the plant and we have to relieve the pressure, we'll open up a valve and it'll open up automatically, and the pressure will go to that stack and will burn off the vapors that come off. So burning it makes it safer and less harmful for the environment. And we use that as a safety device in the case that we have to depressure something. Does that make sense?
Yeah.
Because you don't want it, like a soda can, if you shook it up and it builds up pressure, you don't want it to pop, right? And you don't want it to leak. So if it starts to get too much pressure, we vent it off and then we combust it in the flare stack. These are our steam boilers. So we use a lot of steam in our process. We use it primarily for heating things up, because steam is just hot water, so it carries a lot of heat value. So we can use that steam to heat things up, like the wax that we saw, so that it can turn to a liquid and flow. And then we can also use steam as a motive force to drive things like turbines. So when we walk through the plant, remember all those blue things that were electric motors?
Yeah.
Those turn the pumps and they use electricity. But we also can use steam-driven turbines to turn the pumps instead of using electric motors.
And what this does is it allows for us to train someone who isn't familiar with operating a console. As you can see, there are a lot of numbers, a lot of letters, a lot of different bits of information, but they're all very important to what it is that we do. So what we're gonna do, I'm sure you're familiar with a mouse, and it's a Hulk hand. That's what right here, there it is. So you're gonna double click on that right there. And it's gonna give you a faceplate. So this right here, the SP stands for set point. So it's like driving a car. The set point is your cruise control, where you want it to sit, and then your process variable, kind of where it's at right now. And then the output is how far down you're kind of pressing down on the accelerator. So what we're gonna do is we're gonna set that, let's put it to 5500, 5500, press enter. There you go. So what we're gonna see is we're gonna see this, it's gonna open because we want more feed to come into our unit. Now, as we put more feed into the unit, if you remember, this guy is feeding him, what should the level do? Will it go up or down?
It'll decrease.
That's correct. So as it decreases, this valve here is going to say, oh, I see that it is going down. So that valve should open in order to keep that vessel happy with the level. What do you think?
I think I'm ready. Let's do it.
Okay, that's what I'm talking about. So what this does is it gives the people that we train an opportunity that's consequence free, but to see what could happen.
We've got a few different areas in our lab. This is where you'll find out how much benzenes or toluenes and gasoline, stuff like that. How pure your propane samples are.
They've got something cool for you.
And one of the tests we do is a test for the acidity. It's called neutrality on the jet fuel. This is a simple titration, and we look at the color change on this. So what we're going to do is we're going to weigh this up. Come over and put it on this. We have a scale over here. This is called a tear button, so you tear that, it makes it go to 0. And if you want to try to pour some in there and get that up to around 100, Try not touching. Don't touch this side. Yeah, there you go. Perfect. Carry that over here. Grab it like that. We're going to put 2 squirts of this. This is called a burette. Pull that up. I'll do the first one. I'll let you do the second one. Maybe. So that's 50 mils. We set that for 50, so it puts in a certain amount of solid. I'll let you push it back. So this test is really sensitive to the carbon dioxide in the air, which is what you exhale with your breath. And we've got to put a blanket of nitrogen on it for a couple minutes. This is a nitrogen hose. We'll hook that up here. We'll turn this on so it's up at 600 mils per minute. So that's nitrogen we're bubbling in there, so we're getting all the carbon dioxide out of there. This carbon dioxide will affect the pH of it. Let's see. Push that button right there. That'll start stirring it for us. This is called a pipetter that dispenses a certain amount. So what I need you to do is to stick that down in there, push it down, stick it in there, and lift it up, and then we'll suck it up into this, and then we'll squirt it into there. Let it up slow. Let this up. Lay your thumb up. Put it over there, and now push your thumb back down, and then squirt it in there. There you go. Okay. We'll wait about a minute for this to bubble some more. So this is what we're going to titrate it with. The way this works is you turn this, turn it back, or you can just kind of spin it slowly, and it lets a little bit in and it stops it. You don't want to go too fast because you're going to look for this yellow to turn kind of green-blue. And that's when you're going to stop. So we'll start this. When you look at where it's going to get started, you see there's numbers on here. So we'll try to get it down to it. There we are. So now it's on 1.5. So you're just going to come over here and kind of go spin it like that until we get a color change on it. A little bit more. There you go. So what we would do is we'd take this and we'd look, where we at. We're about 4.5, so we started at 1.5, so 3 mils is what it took. And then we put that into a calculation based on how much weight you got over here, and it comes up with a number. One thing that's cool with this is that your breath has carbon dioxide in it, so now you can kind of just take this, do it into the hood, but blow your breath across it. So you're going to get it to turn back to yellow.
Wow. That's really cool.
And that's how we test it. It's called neutrality with the jet fuel.
Hey Brian, thank you so much for taking the time out of your day to do this. I loved it.
You're welcome. I'm glad you enjoyed it.
I'm excited to see what Chevron has for the future.
Me too. And I'm excited to see the future that you create.
All right.
Thank you.
Man. And as always, check out stemheads.org for more information. Bye-bye.